So how do we calculate it? Let's move on. We now have a formula and the confidence interval. And what would you write down to answer this question? Let's put down everything you'd need to do. Your confidence interval is going to be the x bar figure plus or minus the z figure for 0.995 times by sigma over root n. And in this case, it's going to be x bar, which doesn't need to be repeated again. It's going to be 15.21 plus or minus the z figure. Now, to calculate that, we need to go to our calculator and use it as tables. In stat mode, press execute, go to distribution, F5, go to normal, F1. It's an inverse probability. We're looking for a z value for a given probability, so it's an inverse probability, F3. The area in the left, clearly the area in the left is going to be huge. It's going to be 0.995, 99.5% to the left of that point B, in our case ZB, because here we have our sigma is 1, and our sigma definitely is 1 in the Z distribution, and our mean is 0, and our mean is 0 in the distribution. Press execute, and we get our Z value, 2.57589293. Don't round until the end. 0.5 divided by root 50. Now to do that calculation is a bit messy. We're going to have to come out of that, exit, go to menu, run, execute, and I need to put the figures in to calculate our answer. So that's going to be 15.21 add 2.57589293 multiplied by 0.5 divided by the square root. I'll stick it in brackets just to make absolutely sure. Close the brackets, and there is our upper limit for the confidence interval. So that would be 15.4. We're answering to 3 significant figures. To get our lower limit, we need to back up, use the replay button, delete the addition sign there after the sample mean, and put a subtraction sign, and we get the lower end of that line. That's 15.0, and that's our confidence interval. Now that's a little messy because we had to switch between 2 modes on our calculator, and there is another way, and let's have a look at that. The calculator is designed to do confidence intervals, and all you do is give it the actual parameters. So let's do it a different way. Calculator is going to do so much, you better make sure that you convince the examiner you know what you're doing. And so you don't know the Z value, and so I strongly recommend you give the opportunity to get marks should you press the wrong button in the panic of trying to get through the exam so quickly. So that information is what you're trying to calculate, and at this point let's go back to menu, back into stat mode. This time go to don't go to distribution, sorry, go to INTR and press F4. We are using the Z values, so press F1, and it's a single sample, 1S, press F1 again, and here we are using a variable. We have other examples where we would work from a list of numbers. We're using a variable here, so it's F2. Our confidence interval, our level, be careful, it's not 0.995, it's just 0.99, not 99 either, 0.99, because of course the calculator is going to do everything for you. You don't have to think ahead and work through it. It will understand it's a 99% confidence interval. Right, next stage, you need your population standard deviation. It doesn't ask you to do your estimated standard deviation, it's the population standard deviation, not the standard deviation of the sampling mean. In other words, all you're giving is this figure, not asked to do the calculation here. because it's going to do it for you. Here you need the value for the mean, and that is in, and then we need to give it the sample size so it can do all the calculations. Okay, and there we have it. It gives us a confidence interval which is 15.0 at the lower end and 15.4 at the upper end. And of course you should now see you are ready to go either way and able to calculate confidence intervals for samples where the population standard deviation is known.